know if they can't hear me, that'd be great, but hopefully everybody should be able to. So like I said, we'll be talking about iAIRE. iAIRE is a third-party company that TEC represents here in Chicago. They are a company out of Indianapolis is where they're headquartered and manufactured in Orlando, Florida. And just to move it along, so what we'll be covering today, first we'll just go over an overview of what ventilation means for buildings, how to address it, why it's necessary. Then we'll jump into an introduction of dedicated outdoor air systems just to give you a little 101 basis. We'll get a little deeper into why those systems are important, and we'll also get into some selection considerations for our engineers on the line. Specifically, we'll go over how to choose a supply airflow, exhaust airflow, the type of supply air that you want, that's depending on dew point temperature, as well as dry bulb temperature, and then also supply air distribution, so whether it's being distributed to multiple spaces or to one large space. And then finally, we're going to go over iAIRE as a company and the products that they offer, why they're a superior company, and you know, how they can be the right fit for any job you're working on. So without further ado, we'll jump right into ventilation overview. So ventilation is basically necessary to replace contaminated air, which I'm sure you're familiar with. And generally, we do that by introducing outdoor air, which is considered clean air. That may not always be the case. Those of you that are from the downtown area know that you may not want to be taking in outside air right off the street side. We're going to have to filter that and you know, treat that air more than you would for a building out in the suburbs. So what we're going to try and do is we're going to try and reduce things like CO2, carbon monoxide, volatile organic compounds, smoke and chemicals. Also going to deal with larger particles like dust, dirt, and debris, things, smells, and odors, and then maybe most importantly are some items that present a health concern to a lot of buildings would be bacteria and fungal spores. So that's what we're going to do when we replace the outside air. We're also trying to maintain oxygen levels for occupant safety and comfort. And then finally try to maintain humidity levels. Some of the benefits of ventilation, the major one that most people generally understand is superior indoor air quality. So if you can provide outdoor air that's been filtered and treated, you're going to improve occupant comfort, which in turn is going to reduce absenteeism. So people are going to show up to work more, they're going to show up to the office more, generally because their health is better there. I'm sure most of you have heard of sick building syndrome. And overall, if you can increase the productivity of your, whether it be your staff or your students, you're going to have improved occupant comfort, and your building is going to be you know, a happier building altogether. So I just have noted there some of the proven studies that have been done for indoor air quality in certain buildings. So schools, you see higher grades, healthier students, you know, less absenteeism, like I noted there. And as businesses, so businesses are generally more profitable. They have a building that is clean and comfortable. So the cost of indoor air quality means that you have to treat a wide range of outdoor air conditions. So I have here listed extreme heat, extreme humidity, and extreme cold. Here in the Chicagoland area, we generally deal with extreme humidity and extreme cold, maybe not so much the extreme heat, but we definitely do get those, you know, 80-degree wet bulb summer days in July and August, and then I'm sure most people know that we get extreme cold, design temps -10, but we've seen far below that as well. So being able to treat that ventilation air is important. It will come at a high equipment cost a lot of times, which I'll talk about how iAIRE can help reduce those costs because you are treating such an extreme, either humid or extreme cold climate. It's going to cost energy, and we're going to try and minimize that through delivering the minimum air necessary to provide both occupant comfort and to meet, you know, local or state or national codes. Engineers will generally calculate ventilation just based on ASHRAE 62.1. That basis comes from a CFM per person rate as well as a CFM per square footage area. Although if the building is going for any sort of LEED accreditation, there will be other ventilation calculations to consider there, or if there are local codes, you know, for example, here in Illinois, we have to follow IECC 2015. Any local codes that may apply are also subject to different ventilation calculations. So typically what you might see from an older style ventilation system would be a packaged unit. So in this picture, obviously you see a rooftop unit that is providing both the space, latent and sensible cooling, as well as all the ventilation required for the building itself. The problem with this type of system where you don't have a dedicated outdoor air system where it's all packaged together is we don't really know if each zone is getting the correct amount of ventilation. So you'll see here that it's noted that if you overventilate the space, you're essentially wasting energy. If you underventilate the space, then you're going to have poor indoor air quality, which will lead to the problems we spoke about earlier, which are, you know, poor occupant productivity or less absenteeism, and that's what you'll see with a typical ventilation system. So how do we address that? We address that by using a dedicated outdoor air system, and like the name suggests, this system is only going to provide the ventilation air for the space. It's not going to try and do the cooling and heating that each zone requires. So I'll just jump into a little introduction, the 101 behind dedicated outdoor air systems. And we'll advance a little into the details as we move along, right? So a DOAS unit is an HVAC unit that conditions and supplies 100% outside air. This is going to do all the ventilation to the space. So a true DOAS system is 100% outside air. We will talk about how you may use recirculation or a portion of return air when necessary. iAIRE can do anything between 0 and 100% outside air for their DOAS units, and we'll touch on that briefly. So DOAS systems generally used to provide ventilation to multiple zones. So say you have a school with multiple classrooms, or you have an office with 10 or 20 offices. Generally you'll have one system providing ventilation air to all those zones. There are also examples where you can use a single DOAS unit for a large single zone. So say maybe an auditorium or a gymnasium, but in general we see that providing ventilation to every space helps to, you know, simplify your DOAS system in general. So the main idea behind using a DOAS system is that you're going to provide neutral air to the space. So generally we're going to provide between 68 and 75 degree air at less than 60% relative humidity to each space. And the reason that it should be neutral air is that, say you have 10 spaces, well, they may not all, especially when you have spaces that are individually heated or individually cooled by auxiliary units, they may not all be in the same heating or cooling setting. So you don't want to negatively affect the space by overcooling it or overheating it. So we're going to supply space neutral air. And to supply that space neutral air, DOAS units are typically controlled based on supply air temperature. And they'll also contrast that with using either just an outdoor air temperature sensor or a little fancier outdoor air enthalpy sensor, comparing and contrasting those temperatures to provide that neutral air. And we talked about this, and I just want to note that generally you'll be selecting a DOAS unit based on extreme humidity and extreme cold. So it has to be able to handle extreme heat, but generally, as you would pick or select a cooling unit based on the design cooling day, for a DOAS unit you're going to select based on the design humidity day or design dehumidification day. So like we have here in Chicago, design days of -10 in the winter, your DOAS unit has to be able to provide air at space neutral, so that's 68 to 75. So you're going to need a 70 to 80 degree rise, which generally means these need large heat exchangers. And for each type of situation we'll go through here, so whether it's heating, dehumidification, cooling, you'll see that each one is accompanied by a site chart and a slate, description of how that physically works within the machine. So you'll see here, pretty simple in heating. You've got -10 design air being heated by whether it's a gas heat exchanger or an electric heat exchanger to provide neutral air to the space, which is 75, 55 typically. So some different dedicated outdoor air system heat sources. The ones you are most familiar with, obviously gas heat. iAIRE can also do hot water modifications, so you can have a packaged DX cooling unit with hot water heat. We can do electric heat and also DX heat pump. So you can do a variety of different ways to provide heating to your space, including, which we'll go over in detail later, energy recovery wheels. So what you're going to want to do is provide that space neutral air to the space, and you don't want it to be too moist. So you're going to want to dehumidify that extreme outdoor air to prevent the space from becoming muggy or too hot. And again here, so you'll see outdoor air, the dehumidification design day 9578. We're dehumidifying that and then reheating it back up to neutral 7565. This is just an example of the site chart. So like I mentioned there, all DOAS systems will generally have a reheat system, and this allows you to cool the air down to that design 55 degrees to pull out moisture from the air, and then reheat it to a space neutral temperature as to not affect the zone cooling or heating. And that way you can provide drier air than is typical of the outside air, especially here in Chicago in the summer. And your standard dehumidification sources are going to be obviously DX and chilled water. So again, all of this iAIRE equipment is based around the Carrier platform. So if you're familiar with the Carrier rooftop series, it's going to be your TC, HC, LC, A, N, and P series rooftops. So the whole gamut of the Carrier rooftop series, as well as some of the air handler units themselves, package splits, residential style equipment. So there will be the standard DX evaporator to provide dehumidification. We can also do chilled water coils in those rooftop units, which is not standard Carrier equipment. And then generally, a lot of these units will include a desiccant energy wheel to sort of pre-treat that outside air and pull some humidity out of the air before it even reaches the DX or chilled water heat exchanger. And then as a reheat source, generally there will be DX reheat or electric reheat. And this is just a close-up of how those items line up in a packaged unit. So you're going to intake the outside air, it'll hit the evaporator coil, whether it be DX or whether it be chilled water, and then if it does have DX reheat, that'll be immediately after the evaporator coil, very little space in between, and that allows you to supply that neutral air. So all of these units also include what is considered an economizer mode or a fan-only mode, just like you would with a standard rooftop unit. Now the difference between a standard rooftop unit economizer mode and a DOAS economizer mode is the type of air that it's applying. So as I've been reiterating, that you're trying to supply a space neutral temperature, so you need a different outside air condition than you would with a standard cooling unit to provide that outdoor air only, fan only mode. You're looking for that 68 to 75. You'll see that's more of a rare condition, so you're only going to get it every once in a while maybe, but the units all come standard with that ability. So we'll move a little bit into building pressurization. There's a couple different things to consider when looking at building pressurization with a DOAS system. So first of all, you don't want to over pressurize your space, right? So you're introducing in some cases, a lot of CFM of outside air using this DOAS unit. So either your walls are going to be busting, or you're going to need to exhaust some of that air somewhere. So you could do it with, auxiliary exhaust fans. You could do it with a powered exhaust tied to your DOAS system, where it's still exhausting all the air, but all the return air is, directed towards that unit itself. Or you could have some sort of, barometric relief throughout the building. Now there's two ways to look at it. You could do generally an equal in and equal out, depending on what type of space you have and what kind of application it is, whether you want to negatively pressurize your building or positively pressurize your building. I think in most cases you would generally over-pressurize just a little bit, so you're exhausting less than you are supplying. That way that prevents infiltration of things like dirt and dust through the cracks of the building. And like I mentioned, so a lot of the times if you can drag that exhaust air towards the DOAS system itself in an aggregated exhaust type layout, then you can add an energy recovery wheel and recover a lot of that waste heat that would otherwise go unused. iAIRE can do both sensible wheels only, they can do total enthalpy wheels, and then we can also pair them with fixed plate heat exchangers, which would not be necessarily mated with the unit, but those would be more standalone on the roof, inducted to the system itself. I went through each of those. You can see there on the right what the wheels look like, and on the bottom right there is what the the core heat exchangers would look like. Again, this is just a schematic of the unit itself and how the the airflows change from temperature to temperature as they go through the unit. So you see there the 95-75 outdoor air coming in. It's exchanged with an exhaust air temperature of, you see there, 75-65, leaving the building, being brought back using the exhaust fan through the energy wheel. That leads itself to an 83-70 degree leaving air temperature off the wheel, which becomes your entering air temperature for your evaporator coil, which drags that back down to 55 degrees cooling. As you can see, so you're going now from 83-70 to 55 instead of 95-75 to 55. So you save a lot of energy there, and then again your DX reheat back up to that space neutral temperature. And I'll just read this really quick here. So this is AHRI's definition of a DX DOAS system, just so you can see how they qualify it. It says it is a type of HVAC unit which typically includes reheat to condition 100% outside air to provide dry air at a dry bulb temperature at or near the designed room temperature directly or indirectly to the conditioned space. It may precondition outdoor air by containing an enthalpy wheel, sensible wheel, desiccant wheel, plate heat exchanger, heat pipes, or other heat mass transfer apparatus. So that's just a fancy way of saying, a couple different things here, that a DOAS system, a true DOAS system, is 100% outside air for ventilation. It typically handles the latent load of the outdoor air, so it removes all the moisture. It will almost always include a reheat coil or a reheat electric strip. And then it may also utilize a recovery system, so whether it be core or wheel style ERV. And then this last line here, which I'm going to get into shortly, is that most DOAS systems, because it is a decoupled system, will require ancillary cooling and heating systems per space. And that's what I'm about to jump into here. So generally you'll have in each zone, so say this is a DOAS system that's feeding multiple classrooms in a school. Well, each classroom of that school is going to need its own auxiliary unit. And there are a lot of different types of auxiliary units that are generally matched with DOAS systems. So you'll see there listed at the bottom. A lot of the common ones we see are water source heat pumps, variable refrigerant flow, which again is something that I deal with every day and will always be matched with a DOAS system, unless it is a certain application where you may be able to use operable windows, say like a small multi-family apartment building. You could also match this with duct-free splits individually. We have seen rooftop units as well, vertical package units. Chilled induction beams will almost always require a DOAS system. Individual fan coils per space, residential style splits, PTACs, just about all of those individual zone style ancillary units that you can think of. So the space conditions of each zone are regulated by the auxiliary units, and what that means is because the DOAS unit is conditioning the outdoor air to space neutral, the space sensible and latent loads are going to be handled by the auxiliary unit. The intent of using a system that has space neutral air temperatures so that it doesn't affect the cooling or heating of the auxiliary unit. And that's a generic DOAS system, but we will get into how you can use offsets from the DOAS system to help, depending again on your space use, the type of building, you can help offset those sensible or latent loads of each space. And so like I just mentioned, this is just a little slide on offsetting the latent load of each space using your DOAS system. So you're going to use your DOAS system to control the entire outdoor air sensible load, the entire outdoor air latent load, but then you're also going to use it to do all of the space latent load or part of the space latent load. And you'll see that that helps you decouple what the auxiliary units need to handle. So generally this is used with auxiliary units that aren't very good at dehumidifying air or providing any sort of latent capacity. So chilled beams is a good example of this. Generally they're not great at dehumidifying air, so they will take care of that latent load at the DOAS unit. You'll see here that on the site chart you can see the outdoor air is cooled all the way down past that 55 degrees. That's typical to pull a little extra moisture out of the air, and then it's still reheated back up to consider room neutral. But that way, once the air gets delivered to each zone, it's able to absorb more moisture than it would if you just were supplying air that had been cooled down to 55 degrees. So another way to do it, so we just heard about offsetting the latent load, but you can also offset the sensible load of the space. This is one that you have to be more careful with. So generally, this would be providing closer to 55 degree air in the winter, or I mean in the summer, and warmer air in the winter to offset a little bit of that space load. And I will note that this is possible and often a good idea when you're looking at variable refrigerant flow systems. By their nature, as heat pump systems generally don't provide great heating at low ambient conditions. So a good way to offset that if you are using a variable refrigerant flow system matched with a decoupled DOAS system is to be able to uptick the size of that heat exchanger inside your DOAS system to offset some of that sensible load in the winter. And again, this is just a site chart of that that design in cooling. So you're going to be actually, as you can see in the top left there, you're going to be actually providing cooler air instead of space neutral. So you're looking at 55 degrees instead of the general 70 degrees. And I just want to say that this is a design you have to be careful with, just to make sure that you understand what it's doing to your spaces and whether your building layout or the application is the correct one for using this type of offset. Because if you're constantly supplying cooler hot air to the space, you can potentially cause overcooling or overheating or humidity issues in your space. And a lot of that stems from the fact that not all of your spaces are going to be in the same heating and cooling set point. Some may need more, some may need less, but the DOAS system is providing the same air to all those different spaces. So some of the benefits of using a decoupled DOAS system, one of the major ones is you're going to get improved indoor air quality. You're going to be able to maintain ventilation rates to a much higher degree, proper humidity control, which in turn leads to reduce microbial growth, mold, mildew, the whole gamut of organic matter that grows when there's too much moisture in the air. Proper building pressurization, and then obviously that we talked about earlier, that if you can control all those items, generally it leads to higher productivity in an office setting or a school setting, which at a larger scale can even reduce healthcare costs for a company. You're also going to get energy savings by being able to provide energy recovery to your system, and also by aggregating all of your exhaust and all of your supply to one system. Generally you get an economy of scale when it comes to energy. Reduce first costs. So generally, if you had to provide this amount of ventilation to each space individually, again, you're going to be able to reduce your first costs by simplifying the design, simplifying the install, providing a single piece of equipment versus numerous pieces of equipment. And then finally, you'll be able to meet all of your code requirements generally in an easier manner than you would without a DOAS system. So just to provide a little summary, I won't touch too long on these because I feel like I've hammered them home a little bit. But again, a true DOAS system is 100% outdoor air. It's going to be no recirc. All of the air that is returned to the unit is exhausted, even if there is an energy recovery wheel. And then also that you're going to be able to provide pressure control with that, and then that exhaust air can be recovered. And then finally, so the DOAS unit is generally used to provide dehumidification for the space, not necessarily space cooling and space heating, although you can use it to offset latent loads or sensible loads, depending on your building, depending on the application within that building. So I'll jump into just a few things to consider when selecting, for our engineers out there, when selecting a DOAS system. You're going to want to obviously consider supply and exhaust airflow. You need to consider your dehumidification capacity, where the building is, what the design dehumidification day looks like, how much compressor capacity you're going to require, how much reheat capacity, and then for the winter, especially here in Chicago, heating capacity is especially important. So picking the supply airflow, it's going to be based on a couple things. Obviously, building code, building type, and occupancy will be important. And then that airflow that you choose is going to drive the capacity requirements. So how low of a dew point temperature do you need to provide? And then also, how much do you need to offset the space latent load? How much latent load is generated within your space? And on the same note, how much do you need to offset the sensible load if it is possible for that design? The exhaust airflow, not a whole lot here, but it's going to be obviously based on what your supply airflow was, whether you want to pressurize that building in a positive nature. If it'll be negatively pressurized for any reason, you're going to have to subtract any additional building exhaust. So if you're looking at an apartment building where you have a DOAS system feeding each individual room, but you also have bathroom exhaust fans as required by code in each bathroom, then you'll have to subtract that from the exhaust airflow of your DOAS system itself. And certain zones are certainly specified how much exhaust airflow needs to be dissipated from each of those. And then finally, whether or not you're going to try to utilize an energy recovery wheel or an energy recovery fixed plate heat exchanger, you'll be able to reduce the mechanical dehumidification and heating capacity of that unit. And a lot of times that'll be owner dictated whether or not they want energy recovery or what type of energy recovery they're looking at, or it may be just building a layout dictated whether or not you'll be able to get ductwork back to the unit to provide a singular exhaust versus having multiple exhausts from every single space. So supply air dew point, this is just about choosing basically between the different supply types that we went through. Whether it's going to be a low discharge air temperature with a low dew point, or if it'll be more of a space neutral temperature. Just what is the optimal optimal design for your building in that way. So if you're looking at the two differences here, so here I have listed outdoor air latent load only, so the unit is only going to be sized to pull moisture out of the outdoor air, and that's versus on the right side you see outdoor air latent load and space latent load offset. So if you're only doing the outdoor air latent load, you're going to want a maximum evaporator leaving air temperature of 55 degrees. And I touched on this earlier, but this is generally going to be used when your ancillary units in each zone have the ability to control moisture in that space. So packaged rooftop units are generally okay at that. Water source heat pumps, VPACs, variable refrigerant flow systems can go either way depending on generally the type of indoor unit, whether or not those will be good or bad at pulling moisture out of the air, and then split systems. And then conversely, when you have ancillary HVAC equipment that may not be great at pulling moisture from the air, so for example, chilled beams are often not as good at that. You're going to want to be able to size your your dedicated outdoor air system to offset the latent load. And this is just the site chart of that. You'll see going from 1, that blue line of cooling, down to A or down to B. A would be the outdoor air latent only, so you'll see it's a little bit higher of a dew point, or going down to B would be that lower dew point to offset some of the space latent load. And these are just some of the the pros and cons of those two different designs. So if you're doing the outdoor air only, it's going to be a lower cost DOAS system, obviously, because you're not using such a large unit. But then obviously the contrast to that is that you're going to need larger ancillary equipment, and it's generally a tougher system to control, so you may need more controls involved in that system. And then the system on the other side is basically the opposite of that. So you get to decouple the latent sensible loads and address them individually, which is generally easier. You'd improve space temp and relative humidity control, reduce ancillary equipment size. Generally, you get a higher ancillary equipment supply air temperature, which is important because that way it's even less noticeable to the occupants of the space. So generally, they don't feel in cooling, they don't feel that cold blow that's associated with larger ancillary equipment. But then a con would be that obviously you have a larger size unit. And this is just a quick example that I ran through. So you see there a building with 15 zones, a DOAS unit without latent load offset, and a DOAS unit with latent load offset. So you do increase the size of your packaged DOAS unit by almost 30% there. You can see 230 MBH versus 161. But overall, if you can offset the the cooling coil load of each individual zone, you're saving 17.5% cooling capacity reduction of that system itself. I'll move through these a little quicker because it does touch on some of the same, but dehumidification capacity, it's going to be based on a lot of the same things, whether you want to supply neutral air or if you want to offset the sensible load. Generally, you're still going to require reheat on a sensible load offset, even though you're supplying closer to that 55 that's coming directly off the cooling coil. You still want to reheat that a smaller amount. And just the same type of chart layout here, but for whether you're doing space sensible load offset or not. So on the right is neutral air, which is generally used in systems with higher airflows, low cooling loads, or anything with high humidity. So I've got listed there bathrooms, lockers, and showers, or any exterior zones that are generally off-peak, so maybe they're not on a sun side of the building. Whereas if you want to supply cool air, or aka space sensible load offset for your DOAS system, you're going to see it's more of that dry bulb range of 55 to 65 instead of 65 to 75. and that's going to be used more in general with constant or high cooling load spaces. So it's more common to gymnasiums and auditoriums and spaces like that. This is the same compare and contrast between what the site chart would look like. So this is cool air supplied DOAS. So you see there it cools from 1 down to 2, and it's reheated only up to 3, whereas this would be supplying neutral, where it's reheated much higher. And generally we recommend staying below 60% relative humidity. You'll see here just a small chart of what your supplier might look like, what your dew point might look like. Red obviously is too high there. You're going to have microbial growth. Anything in black is more acceptable for that type of design. And this also, so not only does it protect you from microbial growth and mold and mildew growth, but also has the least impact on your space conditions. Pros and cons. So neutral air is going to prevent overcooling. It says that you're less likely to feel drafts, which was similar to the neutral air from the latent load offsets slide you saw. But also it's going to require a much higher delta T in your reheat. So you have to be sure that the machine is going to be able to handle that. And then on the other side here, you have cool air offset for space sensible load. You're going to be able to reduce the ancillary equipment size, potential reduced energy costs, but generally it's a tougher design to get under wraps, and then also your system may fight against itself in certain types of the site chart. So here are the two different DOAS system arrangements. So you have a series arrangement or a parallel arrangement. And again, there are pros and cons to both, but what a series arrangement is you're going to have the DOAS unit feed directly to the ancillary units in each space. So the return air and the fresh air from the DOAS unit will mix and then be treated by in this example, they have fan coil units there, and then supplied to the space. So what's nice about this is that you may only need a small reheat in your DOAS system itself, because the fan coil units may be able to handle some of that on their own. But also you're going to require constant fan flow from those auxiliary units, because this is providing code-related ventilation air. If those units turn off and it's not feeding anything, then you're no longer meeting that code. So on the other side, to escape that constant running of auxiliary fans in your zone level units, you can feed the DOAS air directly to the space, or you can mix it on the supply side of those fan coils. And again, this is going to require a much higher delta T on your reheat coil, because you don't want to be providing extremely cold air that will mess with the design conditions or mess with the set points of each zone. So I have there at the uses, generally a series style arrangement will be used with low occupancy areas, and a parallel system will be used with high occupancy areas. This is just a summary slide basically of all the different offsets and design criteria that we just went through. So I won't touch on them too much again, but just keep in mind 100% outside air for ventilation needs to be provided to the space regardless of what the ancillary units are doing. DOAS dehumidification is going to be based on design latent day, not the design heating day. And you're going to have to make sure that the machine has enough reheat capacity and enough heating capacity to provide correct neutral air temperature. And you're going to need to, as you select your DOAS system, it should be hand in hand with selections for whatever auxiliary type unit or type system you're using. And with that, I will move into iAIRE and iAIRE's product lineup, what they can offer, why it's superior, and what they're all about. So iAIRE, like I said, is a company that deals with specifically these outside air products. So whether it's DOAS systems or ERVs standalone, they do everything outside air. And at the very beginning, I said that they're headquartered in Indianapolis. The manufacturing is done in Orlando, Florida. And their main goal is to reduce the amount of outside air while maintaining or improving indoor air quality and delivering ongoing operating utility savings. So they make a slew of different things: dedicated outdoor air units, ionization devices, standalone economizers, standalone ERVs, flow monitoring equipment, and then they also act as a sort of chop shop where they can do a multitude of RTU modifications. They can do just about anything. So I'll start with basically their bread and butter, which is their standard DOAS unit, which is called their ultraDRY. So this is ranging from anywhere from 3 tons to 150 tons, and it's built on the Carrier platform. So I said this earlier, but the Carrier units that you may or may not be familiar with, the RTUs are the TC, the HC, the LC, which those are different package units between 3 and 30 tons just based on efficiencies, and then also their larger units, which would be the A series, the P series, and the N series. And iAIRE works with them and modifies all of those units. They basically get stripped down and rebuilt as 100% outdoor air units. And you'll see, again, we can do all electric, we can do gas heat, we can do heat pump systems. They also do packaged split systems. Well, they do packaged RTUs, split systems, water source heat pumps. Just about anything Carrier can also be iAIRE. So I'll go through some of the modifications that they make. The main one is going to be a hot gas reheat coil. So this is a fully modulating hot gas reheat coil. It's added directly downstream of the DX coil, or in some cases the chilled water coil, depending on if that's a modification you make to the machine. And that's going to be necessary for just about any DOAS system. And that comes standard with all of their ultraDRY units. The next is what they use for cooling capacity modulation. So it's a Rawl valve, modulating capacity valve, and that's attached near the compressor, and it will bypass hot gas from the compressor back to the intake of the compressor, depending on how much capacity is needed at that time. And what that does is it reduces the flow of refrigerant to the evaporator coil, which reduces your cooling capacity. Generally, they found that they're more reliable than, say, a variable speed compressor, generally because there's a lot less moving parts to this system. It's a lower cost option as well. They also add to every ultraDRY unit that has gas heat. They're going to add a modulating a modulating gas heat valve, which has a 6-to-1 turn down, fully modulating, and then also, so if you're familiar with what Carrier offers from a heat capacity standpoint, generally you would find that they wouldn't be suitable for Chicagoland design winter conditions, so going from that -10 back up to 70 degrees or even higher in a lot of situations. So they do offer the ability for a higher capacity gas heat exchanger that allows us to use these DOAS units in cold climates like Chicago. They also add to every unit a supply fan VFD. They do that for a couple different reasons. One is to allow the unit to operate at much lower CFMs than originally designed. So, DOAS systems will operate, instead of at that 400 CFM per ton, a lot lower, often into the 100, 180 range. So this allows them to operate the fan at a much slower speed. You can do it at a constant volume or a multi-stage type operation, and they also do full VAV configuration. So it gives you a high energy efficient style unit with a lot of flexibility. Some of the other options that are available on these ultraDRYs, they have a lot of different options. So ionization, which in a lot of areas you're able to reduce the amount of air provided to the space by cleaning it first with ionization. They also do all sorts of coatings. We don't get that a lot here in Chicago, but for some of our design engineers that may work in other states on the coast, they do coil coatings and full unit coatings. They do ERVs, both mated, standalone, bolt-on with no feet, bolt-on with feet. So there's a lot of different ERV options. And then some of the smaller things, motorized dampers, backnet interface. They also do full double wall construction, 2-inch double wall with R16 insulation. They can do stainless steel drain pans and heat exchangers. Just about all of the units will come with stainless steel heat exchangers when they're full 100% outdoor air units. If you don't get the stainless steel drain pan, they already come with a composite built non-corrosive drain pan. So sometimes the stainless steel drain pan is only specified in certain applications, whether it be healthcare or other situations that need that. And then the rest of it, like most rooftop units, you're going to get convenience outlets, disconnects, smoke detectors, and the like of it. ERVs, so the ERVs, like I said, are either mated, which means they're going to be cantilevered off the unit. They can also be standalone if your outdoor air solution to your building is just an ERV only with no package unit attached. They can also do that. They also do, ERVs that are mated to the unit, but if they're large enough, have feet. And I know this may not, speak to the Chicago crowd here, but all of these, especially being manufactured in Florida, are hurricane and seismic rated. So their ultraDRY units are offered in 3 different ways. So the full ultraDRY is going to be 0 to 100% outside air, with the whole slew of modifications that make it a true DOAS system. They also have 2 lighter versions, which would be the ultraDRY 3 or the EconoDRY kit. So you'll see there, like the EconoDRY kit is a lighter version. It's only up to 50% outside air. You're going to get a reheat coil, but it's only going to be on-off. It's not going to be the true full modulating that you get with a full ultraDRY. And so it's just a cheaper option if the system calls for that. And there are 3 different ways to control these units. So they can either be controlled off discharge air temperature, they can be controlled from space temperature, space temp and humidity, and they can be controlled in what is considered their ultraDRY 3 model. I'll go through it. I won't read these because these are from the manual of how they operate. But basically, discharge air temperature control is exactly as it sounds. It's going to either modulate the gas heat or modulate the cooling to meet a specified discharge air temperature. Or if you specify space control, it'll come with its own analog style space temperature sensor that can provide a modulating signal back to the unit. That way, you don't, instead of using a 2-stage thermostat, you get a true modulating signal that will alter the gas heat or alter the cooling to provide that necessary air. And then, so that covers basically their DOAS systems. And then I'll just as a note here, some of the other things that they do. So ionization, if you're familiar with it, it's a low-cost option to clean the air, and generally it gives you the ability to reduce outside air. ASHRAE 62.1 has a note where if you can provide ionization, further cleaning the air, then you can reduce the amount of CFM provided. They do Economizer control packages. Again, it's all built around the carrier platform, so it's built to fit those units. If you want specialized economizers with specialized control, they can do that. They also do flow monitoring, where they have built-in ductwork style airflow monitors, for ease of installation and extreme accuracy. That's another side product that they do as well. All of the options that are available on the ultraDRY unit are also available as RTU modifications. So if you have a regular packaged rooftop unit that needs a modulating compressor, we can do that. If it needs just modulating gas, that's something I see all the time. They can do those sort of modifications to the rooftop itself. And with that, I'll just leave you with this. So AIRE is able to provide some industry-leading, lead times. Generally, they range anywhere between 5 and 8 weeks, depending on the type of unit, the size of the unit, and the customizations that are being made. They can modify just about any type of unit rooftop units, split units, water source heat pumps, self-contained units. I see a lot of that where they'll need a unit modified to be true VAV. iAIRE can do that as well. They're some of the lowest costs in the industry, so they won't gouge you on price. And then also, these are standard warranties generally towards most companies that you see that make DOAS units, but it's going to be a 1-year parts, 5-year compressor, and 26-year stainless steel gas heat exchanger. That accompanied with full factory support and full technical training for contractors gives you just about as complete of an outdoor air solution company as you can find. And that's what I work with. So those of you that work with TEC, you may already know me or work with your TM, and I'll be here to help with design or estimating jobs for DOAS systems, and just relaying any sort of advice that I can for our design engineers out there. So with that, I will leave you my contact information. I'll see here, I probably didn't do a great job of keeping up with the questions, but let me see.
Hey, Danny.
You know what? I'll have all of your contact information for the questions, so I'm going to follow up individually with you just because I haven't been following along with the questions through the presentation. I'll follow up individually with everyone in an email addressing each of their individual questions. And with that, I just say thank you for joining me today. I'll leave the webinar up here for a little longer if you want to type in any questions. I'd be happy to answer them individually with you. So thanks again.